Hi everyone, and welcome to another Tech Talk. There are many videos out there walking you through a manual Arch Linux installation using the official Arch Wiki way. Some of the steps involve very menial tasks like setting up your keyboard, locale, time zone, and so forth. It gets boring very quickly for many of you, and of course for me as well. Naturally, the idea of Arch Linux is all about installing it once, just the way you like it, and then rolling along with the updates until your hardware wears out. But if you're like me, you want to learn and experiment with Linux using your daily driver, and eventually, sooner or later, you will feel the need to reinstall everything from scratch. So you look for shortcuts to speed up the installation process the next time. One such method that is officially supported and baked into the ArchISO media itself is the ArchInstall utility, currently at version 2.5.6. Now you may be saying, great, I'll just boot up the ISO on my computer, run ArchInstall, answer some basic questions, and in a few minutes I have a new Arch Linux daily driver ready to do what I needed to do. Hold up, not so fast. There are some things I believe you need to be aware of going in, and I'm excited to tell you all about them right after this. In my last video talking about setting up an Alma Linux workstation, I quickly went through the process of building your own ArchISO install media using a DistroBox container environment. I just built a fresh ArchISO using this exact method, and I'll be using it for today's demonstration. I'm using a QEMU kernel virtual machine because I'm testing software, not my particular hardware, which will likely have nothing to do with your particular hardware. I recommend testing this in a VM, not actual bare metal, unless you like putting your data at risk for something you might not even want to stay with. So first, I'd like to set the screen resolution of this virtual machine. I'm running at 1080p. So I'll put in here on the boot parameters, video equals 1920 by 1080, and hit Control X to boot. That should fill in the screen better. I'll increase the font size momentarily, but first let's let the VM boot with a fresh ArchISO. And here we go, we're running kernel 6.3.4. Let's increase the font size with set font terminus 128N. There, that's a lot better. Let's check the network connection. We've got a valid IP address assigned. Let's see if we can ping out. Yes, that works. So, if you have a Wi-Fi card, wireless card you'd like to configure, ArchWiki describes everything, but you want to use the IWCTL utility, and then you can do something like station WLAN 0 or whatever your Wi-Fi card is called, then connect, and then whatever your Wi-Fi network name is. And it'll ask you for your password as appropriate, but we won't need to do that here. Again, ArchWiki has all the instructions. So let's check for the processor type. So catproc CPU info shows we're running authentic AMD. You want to know if you're running AMD or Intel, so you know which microcode package to install later. So we're ready to ArchInstall. Let's type ArchInstall and launch the utility for installation. ArchInstall language is English, keyboard layout is US. That looks good. Mirror region, I'm in the United States, so I'll search from the bottom and select United States with a spacebar and enter. Locale language and locale encoding look good to me. For the install drive target, we've got a block device, the VDA, 64 gigs. So I've got that set up already. For disk layout, we'll do it the manual partitioning way with selection. We'll create a new partition. We'll do two partitions, boot and root. For the boot partition, I will select FAT32. This is an EFI machine with a GPT disk partition layout. So we'll start the partition at 1 megabyte. That's pretty much the default for ArchInstall. And we'll create a 512 megabyte boot partition size. And we'll assign the mount point as /boot. As you can see, now the boot flag equals true has been enabled. And we're good for the boot partition. Let's set up the new root partition, which is the rest of the drive. So we'll start with 512 plus 1 equals 513 megabytes. And we'll use 100%, i.e. the rest of the drive. And there we go. And the rest of the drive will be our root partition, Btrfs format, and we'll be encrypting that momentarily. But first, we've got to set up the subvolumes for the Btrfs root partition. We'll make it compatible for both timeshift and snapper today. We'll be using snapper though. We'll add @ as the root subvolume. We'll escape out of compression, and because ArchInstall is a work in progress and it doesn't do compression properly yet, so we'll fix that later. We'll add the @home subvolume, and we'll mount it on /home. So now and @home, we've got everything we need for timeshift, but we need snapper as well, so we'll continue. We'll do a layout like the ArchWiki recommends. So the third subvolume is @var_log, and we'll mount that subvolume on /var/log, and we'll also escape out of those options, compression and no data copy and write. Then we'll add, for snapper, the @snapshots subvolume, and we'll mount that on /.snapshots, as is traditional for snapper. Again, escape out of those options. And finally, for myself, I like to use QEMU KVM virtual machines, which are copy and write. So I call it @images, and I'll mount it on var lib libvirt images, which is the default for QEMU KVM. Those are copy and write images, so I need to disable copy and write for that subvolume, because you don't want copy and write images running on copy and write subvolumes. Check the ArchWiki, it's a lot of badness can occur. Looks like we're good for our subvolumes, so we'll confirm and exit. As you can see, ArchInstall gives you a nice overview of your entire layout, so you can save and exit if you're happy with it. Next, disk encryption. We'll be using encryption today. We'll encrypt our root subvolume. So I'll just type a simple password for myself here for demonstration purposes, 123. So that's going to be the encryption password. And the encryption type will be partition encryption. We'll be encrypting the root partition. For partitions, the root partition is the only one available. So we'll select that, which happens to be Btrfs, right? And there we go. So we can go back. So basic encryption's been set up. I like to boot from the Grub boot snapshots for make that available. So we'll enable Grub install, not systemd. For the host name, archlinux-1, root account is disabled. Let's create our own user account. So my name is Steven as the username. Give myself a super simple password. And I'll make myself be able to become super user. So sudo is true. We'll confirm and exit. For profile, we'll make something very popular. We'll do a desktop ArchInstall. And one of the most popular desktop environments is KDE Plasma. We'll use the alt open source drivers for graphics. If you're on NVIDIA, I'm sorry to hear that. I got rid of NVIDIA about 6 months ago. Pipewire for audio server. Kernels, I like this to be a long-term stability install, so I'll select Linux-LTS. And for additional packages, what I like to do for the KDE Plasma desktop environment install is install the packages AMD microcode. If you're on Intel, instead of AMD, you want Intel microcode. Again, earlier we figured out what our processor is. So we're on authentic AMD, so I'll just stick with AMD microcode. Next, cups for printing. Cups-PDF for IPPS, print anywhere, IPP capability that my printers have. DistroBox, because of course, Flatpak. Firefox for the initial browser. Firewall daemon, so we can have firewall configurations. Git, GNOME-keyring, iNotify-tools for the Btrfs Grub snapshotting, boot from snapshots for monitoring new snapshots as they're created, and have the Grub submenu be updated accordingly. Nano, Nodo fonts, packagekit-qt5 for the KDE Plasma Discover software utility backend. Print-manager for printer configurations. Reflector for mirror management and weekly updates. TLP for power management. It's like, say, if you're in a laptop. TTF-crosscore alike for TrueType font. Also Deja Vu TrueType font. IBM-Plex TrueType font. JetBrains-Mono for programming and text editing. TTF Liberation, KDE Plasma seems to like that. Vim for editing. And so let me just go here, go through the list and check to make sure I don't have any obvious typos. So this is basically the only list of packages you need to enter when you're using ArchInstall. So ArchInstall still makes things easier, even if we're doing everything manually here. Okay, running KDE Plasma, so network configuration should be use Network Manager. Time zone, I'll switch from the bottom here. I am the US Pacific time zone. Automatic time sync is true. Optional repositories, multilib for 32-bit library compatibility. And what you want to do here to save your work is save user configuration, not the other credentials or layout. User configuration contains pretty much everything you need for duplicating your work here on other machines. Save this JSON file and then put it to your NAS or whatever so other machines have access to it if you want to install Arch Linux in multiple machines. So we'll go ahead and launch install. Now the time this takes to install is heavily dependent on your network connection speed, as you might suspect. And so I've done a lot of editing here on this part to cut out most of the boring stuff, but it partitions, it downloads and installs packages is basically what it does at this stage. And then when it's done with that, it offers to chroot into the newly created installation, which we want to accept. Yes, default. So now we're change rooted into the new installed system. So now we have to fix the compression and the other things we've got here. Because ArchInstall just doesn't do this right. So for SSDs and minimal wear and tear on the SSDs, I like to put in no access time, compress equals Z standard. Again, it installed, for the subvolumes, it installed uncompressed, right? So we have to fix that shortly. No access time, compress equals Z standard. So what I mean to say is we have to compress manually on a fresh installation. So we'll do the same thing here. Space cache equals version 2. All that is automatic. Relay time is a bit slower. I find it measurably slower than no access time. So, and I also get rid of the subvol IDs and all these subvolumes. Again, those are superfluous to requirements for the file system table in Etsy. So it's done here. So the final Subvolume here, we get rid of subvolume ID. And again, no access time. Compress equals Z standard. If we had enabled compression earlier, it would put in zlib. ArchInstall would put in zlib, which is something I don't want. I want Z standard. It has best performance for my hardware. And I think you probably will find the same for your hardware. Again, ArchInstall is a work in progress. These are one of the things they'll have to finish hopefully soon. The next version, maybe. So, because it's installed uncompressed, we're going to have to manually compress our installation with Btrfs, file system, defragment, and then recursive, verbose, and then the compression is Z standard, and then / for root, so the top level. And there it goes. So it compresses all the files that are already installed, and all new files that you add or remove will be compressed going forward. So everything's compressed. Compression is repaired. So let's enable some services. Avahi daemon for network discovery, for network services discovery, like MDNS, right? We also like to enable Bluetooth, since I like to install this on laptops and Bluetooth enabled hardware. Enable cups for printing. And also, we want to enable firewall for firewall configuration, very important for basic system security. So we'll enable that. Again, ArchInstall doesn't enable these by default, excuse me. So these are the things you need to be aware of, right? So we enable TLP for power save. So ArchWiki suggests we mask the radio control systemd-rfkill.socket for our Wi-Fi and Bluetooth radios, right? And also we want to mask the rfkill.service. That just redirects it to dev null. So that system service is, those system services are masked. Next, let's enable uPower. That's standard. And ArchWiki explains what's behind all these services that I recommend. So let's configure Reflector. Let's edit the reflector.configuration file. It's an etc xdg reflector. And we'll leave this as, and all the defaults is fine. We're in USA, so country code is US for myself, and we'll let everything else be at the defaults. So we're good with Reflector. So now what we can do is systemctl enable Reflector. I can type .timer. So once a week or so, it refreshes your mirror list for package repositories, right? All right, so now we can exit from our chroot environment, reboot with fingers crossed, and here's our freshly installed system. And enter our passphrase for the encrypted root partition, dev VDA2. And here we go. Nice and snappy. It's pretty fast. It's we're on Wayland here. Considering this is a virtual machine, this is fantastic. QEMU KVM is basically bare metal performance without the risk of messing up your system by reinstalling and then maybe messing with your data. VMs for the win. So let me do some quick settings here to make this hopefully more legible. Go with Breeze Dark and clicking selects. So double click opens. That's the behavior I like. Let me fix the screen resolution. So we're on 1080p. And for global scale, I'd like 125% so that the fonts aren't too small. That looks okay. We'll keep it. The fonts are blurry. We'll fix that momentarily. We turn off power saving or energy saving. And we also like to disable the screensaver. So let's type sav. Screen locking, lock screen automatically. Again, the fonts are wonky. I'll fix that momentarily. So we'll turn off screen lock, auto screen lock. And if I go down here to about the system, yeah, those fonts are nasty looking. So that's KDE Wayland for you. So let me log out and log back in again. 1, 2, 3. And the fonts should be crisper now. Let's test this. Yes. Now the fonts are more legible. They're small for you. Apologies for those of you on phone screens, but it is what it is. So, there we go. We got the basic settings configured for KDE Plasma. So KDE Discover, there's an error when it launches, no metadata URIs for vendor. So you just go into settings and disable vendor directory, vendor automatic. 1, 2, 3. And that should get rid of that error message. So let me close Discover and relaunch Discover. Again, I recommend with Arch, use the command line for package management, yay and pacman. But if you like it, like if you like to search for your perfect flat packs, you can use the FlatHub repository using Discover to discover new Flatpak packages, which are awesome for a lot of people, including me. So let's open up the console, because we've got a lot more work to do here to make this ArchInstall usable as a daily driver, right? That's the purpose and mission of this demonstration today. Let's check the mount options to make sure we've got the correct Subvolume mount options. So no access time, compress equals Z standard, level 3 as expected. And it added in automatically space underscore cache equals version 2. Don't need to put that in the file system table. Keep the file system table short and sweet. And the Btrfs will take care of the rest, even for SSDs. So let's take care of the AUR handling with yay today. And I'll git clone from the yay-bin repo to speed things up for this video. Won't make it too long, hopefully, today. So yay-bin can be made with make package -si. And there it is. And we'll just install it. So let's cd to the home directory, /home/Steven. Let's run yay by itself to test, and it looks like it is functional. So we can remove the build directory with rm-fr yay-bin. Okay, yay is done. Let's use it. Let's type yay-s, and then I like the Microsoft Core, the old Microsoft Core web fonts on my system. I just like it for tradition. So we'll just install this here. Those are the Microsoft TrueType Core web fonts. Here we go. Okay, I think we're done with fonts today. And yay is functional. So next, let's deal with Snapper and Grub booting snapshots and friends. So we just do the AUR package snapper-support. That pulls in all the dependencies we need for Snapper and booting from snapshots and Grub-Btrfs. As you can see, automatic snapshots if you add or remove packages, all that's taken care of with Snapper-support. So creating config failed, as you can see, because this .snapshots directory already exists in the subvolume. So we'll need to fix that to complete the installation of Snapper-support. So let's first umount /.snapshots, because once that's done, it no longer exists, right? Because we can also then remove /.snapshots and then create our config. So we do with sudo snapper-c root create -config /. That's our basic root snapper configuration. You can do the same for home as well. you need home snapshots. Okay, so that worked. So now, of course, it created an extra snapshots subvolume called .snapshots, in addition to @snapshots, which we configured via the file system table, right? That's extra snapshots subvolume we have to get rid of by doing this. Sudo Btrfs subvolume delete /.snapshots, which is superfluous to requirements. All right, now if we do a subvolume list, you can see the extraneous .snapshots subvolume is gone, but we still have our @snapshots available for the whole snapper system to continue to function. So let's recreate the mount point, sudo make_dir /.snapshots, and then we can mount it again with sudo mount-av. And as you can see, everything's already mounted except successfully mounted the /.snapshots directory. So we're back in business according to the file system table. Sudo snapper ls shows we have no snapshots done yet. We just have the single number 0 current state, which is not a snapshot. It's just the file system current state as installed. So let's let grub know with sudo grub-makeconfig-o boot grub.cfg, and that should set up the grub Btrfs snapshot subvolume. No snapshots found, like I just said, but the configuration was successful. Got a success message there. So grub-btrfs seems to be functional, but now we need to monitor it for new snapshots. So how do we do this? By enabling with sudo systemctl enable now please grub-btrfs daemon. So what it does is it uses inotify to monitor the /.snapshots directory or subvolume for new snapshots and then populates the grub submenu accordingly. So if we check the status, you can see it's now, the daemon is now watching /.snapshots for new snapshots. And we'll test this going forward. So let's clear the console. With Control-L, by the way, is the shortcut for clearing terminals and consoles. Let's install NeoFetch to test the auto snapshot system. So it creates a pre-snapshot, number 1, and then a post-snapshot, snapshot number 2, for the root configuration, for installing a package like NeoFetch. So if you do a sudo snapper ls, you can see there's a pre and post snapshot number 1 and 2 respectively. So every time you do a pacman or yay operation, it does that. So let's test the subvolume menu for booting from Arch Linux snapshots. As you can see, the grub submenu is functional. To speed things along, we won't be doing that today. I covered this in other videos and other channels cover this extensively. So we'll just boot with the default entry and move right along with our configuration. So here we go. And we're back into our KDE Plasma session. So next, let's launch the console. So we have file system trim timer enabled. That's what ArchInstall does, but we don't have any discards enabled, right? You can select one or the other. But ArchInstall doesn't set crypt encryption correctly with discards, so we have to fix that. Let me show you. So we do crypt setup status crypt LVM as configured by ArchInstall. You can see that there are no discard options available for file system trimming, right? No discard. We need to fix this, right? Because otherwise fstrim timer and fstrim.service, which is enabled by default with ArchInstall, will fail for the root partition, right? So if I do sudo fstrim manually, trim the file system, -v/, you can see the discard operation is not supported because ArchInstall did not set us up correctly. One more thing you need to be aware of. That's why I'm making this video today. Very important that you have trim enabled on your solid-state drive. Otherwise, it eventually slow down and fail. So you can fix this by just typing sudo crypt setup refresh --allow -discard, discards, plural, and then crypt LVM, which is what ArchInstall calls the encrypted logical volume. And let's enter the passphrase, and there we go. So now we should have that option. If we do the status again for crypt LVM, we got the new line here, flags, discards. So technically discard should work. Let's try it. Sudo fstrim -v. Bingo, trimming works. So we have a whole bunch of empty space here. We don't have that many gigs installed, so it trimmed the empty space on the partition. So 58 gigs trimmed. All right, so let's do one more check here. Let's sudo systemctl start fstrim file system trim.service. Let's manually start it. It's done via timer already, but we just want to check and see if it's successful or not, because otherwise it would fail. So it looks like it's success. Everything's in the green. It trimmed /boot and /. Both VDA1 and VDA2, which is encrypted. Wonderful. So trimming is working, and the timer will take care of it for you automatically in the background. If you check how it does that, so you do status timer, it it does discards unused file system blocks once a week. Perfect, as default in Arch. All right, cool. So now our ArchInstall is working properly, I think, for a daily driver. So there you go. No video can cover every contingency, but I believe the process demonstrated today should give you a good foundational installation of Arch Linux, ready for further adventures of your own. To that end, I'll leave a link to the Arch Wiki General Recommendations in the description below. I hope you found this demonstration useful for your own needs. If so, please smash the like button, subscribe, and ring the notification bell so you don't miss future videos. Until next time, take care and have lots of fun.